Okay, so we were talking about chapter 3. Particle. So last time we say that when you have this kind of problem, there are certain procedures you want to follow. Step 1, if you see a problem, the first step is to identify what are given and what you need to find. Essentially, I'm asking you guys to rewrite the problem statement yourself, because if you don't know what the problem is talking about, how can you get me a correct answer? So that part is a very important thing that you need to do. And after doing that, most of the problems you encounter this semester is going to be force related. If you do have force involved in your problem, the next thing you need to do is what? Free body diagram. This is very important thing. If you fail to do that, the cost of the problem is going to be almost 1/3 of the problem itself. Okay, so be sure you draw your free body diagram and ensure you include all the required force in this diagram. If you fail to include all the forces in this diagram, you're going to make a mistake somewhere. Okay? Once that is done, then there are a few things you might need to do because we are in chapter 3 now. So if this is two-dimensional problem, then you need to decouple all the forces into what? X direction and Y direction. If it is three-dimensional, what you need to do? You need to decouple the force into X, Y, and Z. When we say it's X, Y, and Z, what do we need to do? If it's 2D, nothing fancy, right? If it's 3D, then you have other steps you need to follow. One is find position vector. So when we are talking about position vector, what do we have? We know the starting point. We know the end point. So the position vector is what? End point minus start point. Okay? So once you get that done, what do you need to do next? You need to find out the length of this position vector. Then you divide this position vector by the length, which you get what? Unit vector. Okay? When you get unit vector, what's the next? You multiply your unit vector with the magnitude of the force. Then you get the force vector projected out to X direction, Y direction, and Z direction. Is that clear? Everybody understand how I'm coming to? So once you figure out those three parts, what's the next? Equation of equilibrium, which means the force along X direction, Y direction, and Z direction, they are all equals to 0. Then, for sure, you're going to have some unknown you need to solve. Then that's the next step. Solve for the unknowns. So essentially, you only need to have 4 steps. Identify, given, and find. Draw the free body diagram. Put, no matter what you do, find out either it's 2 equations or 2-dimensional problems, or it's 3 equations for 3-dimensional problems. If it's 2-dimensional, just use those 2 equations. If it's 3-dimensional, it's going to be a little bit tedious, but you just follow the procedures you should be able to find the force projected along x, y, and z. Then over here, it's going to be a little bit tricky because sometimes you might have 2 forces, sometimes you might have 4 forces. For instance, the one problem that we talking about yesterday, there are 4 forces, but 3 unknowns with them. The weight of the object in the problem is the 1. You guys always skip, so be sure you include that 1 when you are putting those 3 equations together. Then once that's done, you can just solve for the unknowns. Okay? One important thing is, if you are dealing with 2-dimensional problems, how many unknowns can you have? 1, 2, or 3? 2. Why is that? Because you only have 2 equations, right? If you have 3 unknowns and you are dealing with 2-dimensional problem, can you do that? No. So for 3-dimensional problems, how many forces you can deal with? 3, 4, 5, or more? How many equations we have? 3. So how many unknowns we can deal with? Yes. If you have more than 3 unknowns, you either make something mistake or you need to find another equation. We're going to talk about a trick in chapter 5, but in this chapter, if you have more than 3 unknowns, you're doing something wrong. Okay? And yesterday we were talking about the traffic light problem, and today I'm going to finish up this chapter with another example. Then we move to chapter 4. I think I'm a little bit ahead. So this problem is So I have a 3-dimensional configuration like this, and determine the force needed in each cable to support this 100 kilogram load. So, well, maybe I should add another step over here, because before you start, you always need to identify whether this is English unit or metric unit. If it's English unit, I'm giving you the weight of pounds. Do you need to multiply the pounds by gravity? No, don't do that. Do not multiply the number with 9.81. And again, it's the most common mistake you guys make in the exam. Okay, and this problem is metric unit, and the number I'm giving you is mass 100 kilogram. So in order to obtain the force, what do I need to do? Multiply that by gravity. In this case, what is the number of the gravity? 9.81, not 32.2. Okay, so be sure you know that. So I'm given the load equals to 100 kilogram. If you want to do, you can just say it's weight. equals to 981 units here. It might be easy. And I need to find the load. TAC, TBC, TBC. So let's start. Okay. So over here, I know the three-dimensional free-body diagram is a little bit difficult to draw, but we can try it. It's going to be wait. And we have TBC. We have two horizontal forces lie on the same plane. They are TBC, TAC. And of course, I need to identify the x, y, and z directions I want to use. So in this case, I would like to use this one as my x, this one is my y. So in this case, I know this is positive, this is positive, this is positive. Is it clear? Everybody understand what I'm talking about? The reason of drawing free-body diagram has one important definition, which is define which direction is your positive, which direction is your negative. So that everything you write down the equation, just follow what I'm saying over here. Okay? So now, this is my problem statement. This is my free-body diagram. So what is the next step? Step 3. Either it's two-dimensional or three-dimensional. And we need to find out the force on individual axes based on two-dimensional or three-dimensional. In this case, we're dealing with three-dimensional. So there are 4 more steps we need to do before we can say all the forces on x, y, and z axes equals 0. Okay, so let's start doing that. Okay, so what is the first thing we need to do? Position vector. So when I say position vector, what is your end point? What is your start point? Which one is your starting point? C. Very good. So AC, CA, CB, and CD needs to be defined. So we start from this point. So CA is going to be 2I. Is 6J 0. Okay. And this one is going to be negative 2I plus 6J plus 0. Okay. This one is going to be 0I minus 6J plus A. Okay. They are all meters. What is the next we need to do? Length. So to find the length, you just take the square root of the square summation of squares of this value, this value, and this value. Then you get it. So we can do that. CA equals to 2 squared plus 6 squared. That's 6.32. This is actually the same as CD because they are the same numbers. I'm not going to write it down again. So CD equals to 6 squared plus 8 squared. So there's 3, 4, and 5. So it's going to be 10. So far, any question? No? Then the next thing we need to do is to find the unit vector. What do we deal with the unit vector? This vector divided by the length. Right? I'm not going to write it down because I want to deal with this one directly. Okay? So when I say I want to find the force vector, what do I need to do? Multiply unit vector with the force directly. Then I got the force vector. Right? So with that said, ECA, might be better if I define that in different ways. Okay, CA, CB, and CD. So if I do TCA, it's going to be this number divided by 6.32 multiplied by TCA. Does that make sense? Everybody understand what I'm talking about? So if we do that, it's going to be I plus this number divided by this number multiplied by TCA magnitude, which is going to be do I have anything in K? No, right? Because this is 0. So deal with T, B, B, C. It will be the same, but the sign is going to be a little bit different. Same for T, C, D. In this case, it's going to be this number divided by 10. So it's going to be, I will start from here, 6.6 TDC J plus 0.8 EDC K. The reason I did this one blank is I want to align I, J, and K together. So, do I still miss any force over here? How many forces in the free body diagram? 4. So, how many forces I put over here? 3. So, I need to have another one, which is what? Weight. This is downward on z axis, so it's going to be negative 981. Okay. So far, any question? So I finished first step, second step, and third step, and I get over here. What is the next step? This one. I haven't finished this part, I'm sorry. I need to write down the 3 equations for x, y, and z. Right? So let's do that. So how many forces I have here? 2. So by combining x direction, y direction, and z direction, I got 3 equations. How many unknowns I have? 1, 2, or 3? 3. So can I solve for all the unknowns? Yes. So from the first equation, x, obviously TCA equals to TCB, right? So if you want to, you can just replace TCA with TCB or TCB with TCA over here. So you get 2 unknowns in the second equation. But that is not something I want to do right now. I want to deal with the third equation now, because by solving the third equation, I got PDC directly. So if you do that, you're going to find PDC equals to 981 divided by 0.8, which is going to give me 12,000.6 Newton for my cable line of PDC. That's my first answer. For the second answer, I can just plug everything here, so that I get so if you do this, you're going to find TCA. Well, you can write it down, say it equals to TCB directly. And by solving this, you're going to get both of them are 387.5 units. So be sure you mark which ones are your answers. And that completes the solving procedures of this kind of problem. Any questions? Is that clear? Everybody understand what I'm talking about? So for this kind of problem, for chapter 3, nothing fancy. You just follow the steps to get all your answers. What I'm asking you in the exam is, even though you might make some mistake doing the calculation in particular, here, you might wonder why I get the value this weird. Don't worry about it. Just follow the steps and showing me you understand what I'm talking about. Showing me you understand how to get to the answer. Even though you make some mistake in calculation, you might find out your force is actually negative for some reason, and you think it's not correct at all. Don't worry about it. Just write it down. Don't blank out in the test, because if you blank out, you're going to be in big trouble solving other problems. So just follow what I say in class and write down everything. I promise you, I'm not going to be that mean, saying you don't give me correct answer. That's totally wrong. I'm not going to do that. Okay, I'll give you partial credit if you show me the correct procedures. Okay, but don't leave the page totally blank, because if it's blank, as I said yesterday, I won't be able to give you any credit. Okay? Question? No? Then we're going to talk about